In this lesson, we're going to put together everything from the last 3 days. So parent functions, reflections, compressions, and stretches, and also translations, left, right, up, down. So when we have a parent function, there are 4 different spots you can put numbers. Okay, the A, the K, the D, and the C. Now that can be awfully hard to remember sometimes. There's so many different parts and pieces. So what I'd like to talk about is things inside the brackets affect x's. This is an x thing, this is an x thing. If you see a bracket, it's an x thing. Things outside the brackets affect the y's. Okay, so the A and the C, the vertical things. Now remember, the things that affect the y's do exactly what they look like. So you see a 3 out front, multiply by 3. You see a plus 2 out at the end, add 2. But things inside the brackets affect the x's. They do the opposites. So the ones in here, you have to divide by the k value, and you have to do the opposite sign as whatever the d says. If it says add, you actually have to subtract. Okay, so it takes a little bit of practice. We're going to try some today and see how we do. Okay, so all I want to do in these questions are describe, talk about what's going on. So I'm going to label some things. Outside the bracket, that's a y. Inside the bracket, that's an x. A 3 outside in front, that's a vertical stretch by a factor of 3. Inside the bracket's an x. X's do the opposite. It says subtract 2, so I need to add 2. That moves things to the right. There's my 2 descriptors. Okay, let's try the next one. I got all kinds of parts and pieces going on here. There are actually 1, 2, 3, 4, 5 different things going on. Y things outside, X things inside. So let's work with the negative sign first. What does that do? That's a vertical reflection. Okay. The 1/4, that's a Y thing, so it does what it looks like. It's going to compress. It's going to multiply everything by a factor of 1/4. The 2/5 inside the bracket, that's a horizontal thing. It's inside. It's an X thing. X's do the opposites. I need to divide by 2/5. Well, if I divide by 2/5, that's the same thing as saying 5/2 times. That's bigger than 1. So that's a horizontal stretch by a factor of 5/2. We want to turn to a decimal, 2.5. Okay, the +1, that's an X thing. X's do the opposites. So I have to move left 1. And the -7, it's a Y thing, so I have to go down 7. And all kinds of parts and pieces in there to keep track of. And let's look at letter C. Now C's got a trick to it. And before you even worry about trying to figure out what's going on, C is not in the right format. Okay? Equations must be in the form y equals f, and then I need to have one operation per bracket. Okay, the k and the h have to be in separate brackets. If they're not, like this one has a k and an h in the same bracket, you have to factor. In particular, common factor. So we need to fix this before we ever start. I need to common factor out the k. I take out a -2. If I divide 4 by -2, I get -2. And now I can see the k and the h, and they're in separate brackets. It's not going to affect your stretch, compress, or reflect, but it will definitely affect your left and right. Okay, what's going on with this one? What do we see? Well, the k is a horizontal, and there's 2 parts to k. There's a horizontal reflection, it's a negative sign, and there's also the horizontal compression. And we've got to do the opposite, right? By 2. The h says subtract 2, so I actually have to add 2, which means I'm going to go right 2. Okay, so lots of parts and pieces to keep track of. The easiest one to lose track of is the negative sign. Make sure you talk about reflections when you see negative signs. Right, we're going to try graphing some now. So I've got a function, some random function made up of points. We actually looked at this one before, but we'll use it again. What can I do with that? Well, I can make tables if I have points. Now here, I'm going to use a table because there's lots of parts and pieces to it. 0, 0, 2, 3, and 4, 0. Now that also asks for domain range, so I might as well write those down from our original graph. We know we can transform domains and ranges. So x goes from -4 to 4, and range 0 to 3. Okay, transformation time. Things that affect the y's are on the outsides. A y, and a y, and x is on the insides. So what do we need to do to y? I need to take -1/2 of them, and I need to add 1. And the x's, it says subtract 2, so I have to add 2. I can do that to both my table and my domain range. Add 2 to my x's. That's easy. Okay. -1/2 of y plus 1. So 0 times -1/2 is still 0. You add 1, and you get 1. Half of 2, and negative of that is -1. -1 plus 1 makes 0. So remember, we're doing all of this on each of these, right? Now the zeros are nice because we already know what they come out to. We've already done that one once. -1/2 times 3 is -1.5, plus 1 is -0.5. Okay, I can do a domain range right now. I got to add 2 to my domain, so 2 and then 6. And my range, I got to do a -1/2 plus 1. Well, -1/2 times 0 is 0, plus 1 is 1. And -1/2 times 3 is -1.5, plus 1 is -0.5. Remember, we had the negative sign in there, so my signs have to flip directions. And if you don't like writing like that, and lots of people don't, because you really should have the small one on the left, you can just rewrite it in the other order. Okay, that's graph. -2 and 1. 0 and 0. 2 and 1. 4, 1, 2, 3, 4, and -0.5. And 6, 1, 2, 3, 4, 5, 6, and 1. The hard part is you gotta make sure you connect them in order. Okay, so does it look like what it should look like? Has it been reflected vertically? Yeah, it's upside down, right? It used to be sort of the M, now it's a W. Has it been moved? No, it's over to the right and it looks up. Yeah, it's kind of hard to tell those ones. And has it been compressed vertically? Well, that definitely is true. It's not nearly as tall as it used to be. Okay, let's try another one. Instead of making graphs, though, we're just going to make tables. Because once you have the tables, making the graph is no difficult. You just got to put them in the right order and connect them together. But I want to work with the parent functions. So let's think about the parent function for these, if you will. I see root signs. Oh, root signs. I know that parent function. It's 0, 0, 1, 1, 4, 2, 9, 3. My domain has got to be greater than 0. My range has to be greater than 0. I want to transform it. Okay, we can do that. That's a y, an x, an x. 3 y's. X divided by 1/2 minus 1. Now that's tricky to work with. So what's x divided by half? We know it's the same thing as 2x. Right? When you divide by a fraction, it makes a whole number. New table. 2x minus 1 is -1. 2 times 1 minus 1 is 1. 8 minus 1 is 7. 18 minus 1 is 17. Triple the y's. That was easy. Okay, double the domain and then subtract 1. And our range, got times it by 3, and that doesn't actually change it. Okay, now it's hard to check because you don't have your graph anymore, but look at your table. Are all the x's bigger than -1? Yes. Are all the y's bigger than 0? Yes. Okay, let's try B. Now B is working with the same parent function, right? It's still an absolute sign, or sorry, a root sign. We're just doing different transformations. So off the green table, make sure you're using the green table. Outside the brackets, inside the brackets. Double the y's, add 2. Opposite of x's, add 3. Okay, off the green table, add 3. So 3, 4, 7, 12. Double the y's and add 2. Double the y's and add 2. There's our new one, our domain. And I need to add 3, so greater than 3. And the range, I need to double and add 2. So double and add 2. Check to see if it matches my table. Yep, greater than 3, greater than 2. Perfect. And I got one more of these here for us. Letter C. Letter C. Okay, still the same parent function. So we're still working up the green table. We're just going to do something different with it. What do we got going on here? Oh, tricky here. Look at this bracket. It's got two things in the same bracket. Did you notice that before you started? I hope so. Really, this should be like that, right? I can only have one thing per bracket. I got one thing here, one thing here. Remember, the root sign acts like a bracket. So what's going on this time? Well, off my green table, this is a y thing outside the brackets, x thing inside the brackets, x thing inside the brackets. I'm doing the opposites. So I can use my green table. I went up here. Let's move it down so we can see it. Can I move it? Yeah, I can move it. Okay, and we're going to take this table and we're going to do this stuff to it. What are we going to get now? We're going to get, all right, divide by -1 and then subtract 2. Divide by -1 and then subtract 2. Okay, and the y is going to multiply by -1. Okay, our domain range. What happens when I divide by -1 and then subtract 2? I'll get the -2, but I got to flip the other direction. And remember on our original one, sorry, it's up above, but originally domain is like this and range is like this, right? So on our new one, I got to flip my direction. X has to be less than -2, which if you look at your numbers, every one is less than -2. -2, -3, -6, -11. My range, I got divide by -1. Well, 0 divided by -1 is still 0, but that sign, I got to flip directions. So all my y's are less than 0. Perfect. And that's exactly what I want it to be. Okay. Okay. Homework. That's it. We need to practice these things when they're all mixed together. Sometimes when you have more parts and pieces, they actually seem easier, but you need to practice these because that's kind of the big concept for this entire course. We're going to keep coming back to transformations of different kinds of functions. So you need to know your parent tables, your domains and ranges, and then which thing affects which direction. Is it an x and a y, and how does it affect it?